which trains students in complex engineering skills whilst they compete. The participants are mentored by eYantra engineers with exceptional guidance and engagement through project-based learning. The winners are awarded a cash prize, a summer internship by eYantra, and the chance to visit the IIT Bombay campus. The outcome is that students excel in their placement interviews.
Do you want to start?
Do very well in applying for postgraduate studies, both in India and abroad, or many of them do startups to solve real problems in society. So join us. The registrations for the eYantra robotics competition start every year on the 1st of August. Selected teams get exciting hardware kits to solve the problem in their competition fields.
Young people in very hardcore and complex engineering skills at a distance. And we do it with large numbers of students. Like, for instance, the registrations of the eYantra competition, robotics competition, are on at the moment. And through the competition, we train students because students love to do competitions. So we've packaged all the Gyan into competitions and we train large numbers of students, 30,000 plus every year, and make them capable of landing really good jobs afterwards in placements, make them capable of going for higher degrees at the best universities, both in India and abroad, and make them capable of even doing startups. A lot of spontaneous startups have happened as a result of the experience that students like you have got in our competition. Like, for instance, there's a startup called Drona Automations in Bangalore, which does sewer cleaning robots. There's a startup that makes drones for surveying mines, for instance. There's a startup that does robotic rehabilitation equipment. And these are hardcore, engineering startups, not like these startups which are based on data and apps and websites and stuff like that. They are actually manufacturing engineering products. Like, there's a company called Catamaran by Muthu Vangaliappan in Coimbatore, which is doing mobile robots. He's selling security robots to companies in Singapore to patrol their campuses. A few weeks ago, when I spoke to him, he was in a 7-star hotel in Singapore selling them delivery robots. So this is what happens when eYantra contacts young people. You get very, very strong engineering skills. And this morning, what we are going to do is just give you a little sampler, a little flavor for the kind of skills that you learn in the competition. Registrations began on the 1st of August and they are open until the 25th, I believe. And this is a 6-month-long competition through which you get trained in the kind of skills that you often don't get at college. Skills like building control systems for drones, learning Verilog to program reprogrammable hardware like FPGAs, learning functional programming languages, right? Nobody realizes in India that functional programming is a very powerful programming paradigm. The entire WhatsApp system has been built by about 35, 40 engineers. And it's a billion-dollar company. And how do they do it? By this high-tech tooling called functional programming languages. We teach this in our competition and so on. I won't go into details of that, but I'd like to welcome you here. We have a colleague of mine called Smith Kesaria. He, like you, like other students, he came to us through the competition. He became project staff, and now he's doing his master's at IIT Bombay in the Systems and Control department, right? So he will share with you the kind of stuff that we train you in the drone-based themes of our robotics competition. Okay, so I'd like to hand the floor back here to Ruchi, my colleague, and thereafter to Smith to continue the session. Over to you, Ruchi.
Yes, sir. So I think we can directly start the session. So directly,
Any
Smith,
questions, by the way,
over to you.
before we start?
Sorry, sir.
Any questions from anybody? You can raise your hands and ask me a question if you like.
Yeah.
Okay, no questions at the moment. You can ask the team if you like afterwards, right? So thank you. All the best. God bless. Take care.
Smith, you can start.
Audible and visible clearly? Yes, sir. I assume I am audible.
Smith, we can't hear you.
Was it?
We can't hear you. Your voice is very soft.
Okay. Am I audible now?
No, you're not audible.
Hello. Hello.
Your voice is very faint here. I think you're using a headset. Maybe you should just use the laptop mic.
Okay. I'll do that. Yeah. Am I audible now?
This is much better. What have you done?
I just connected my headphones.
You disconnected your headphones, right?
No, I connected. I connected it and using the mic of the earbuds.
Okay, good. All the best. Take
Okay.
care.
Yeah. Thank you. Okay. Then we'll start. First of all, welcome everyone. I think it's still morning, so good morning. And as you all know, you have some idea or some expectations from this session. So this session will be a beginner kind of a technical session for things around drones, things around aerial robots in general. So I think some people had questions in the start, and I can see so many questions. So what we'll do is there are some questions about the theme also, this year's theme. So we'll take those questions at the end, and we'll start with our session today. So let me share my screen. Yeah. Is my screen visible? Ruchi, can you just,
Yes.
yeah,
Yes, it is
it's
clear.
visible in full screen, right?
Yeah.
Yes, sir, is visible.
Okay. So let us start. So as you all know, this session is all about drones, and it is presented by eYantra team and with Kavi Arya as a principal investigator and myself who will be conducting this session. I'm Smith Kesaria, as Ruchi introduced myself. That I am a student of masters in IIT Bombay. Previously, I was also a participant of eYantra. Then I joined eYantra. I am a staff member of eYantra also. And in general, I am very, crazy about drones, very interested in drones and aerial robots in general. So, yeah, that's about me. And okay, we can start the session. So, let's just first discuss about our agenda today. So, these are the 6 points that you all saw in the poster also. So, what we'll do is first just introduce ourselves with aerial robots, and then we'll specifically look at quadcopters and their workings, and then we'll just get to know how do I make a quadcopter? How does one make a quadcopter? Then we'll see some little technical details about the control systems in drones, and then we'll just go through about the high level planning, and finally just the applications of the drones in general of quadcopters in general. So let's start with the introduction to aerial robots. Now, what does it come to your mind when you hear the word drone? I'm sure most of us here might have saw or seen or heard about drones in the movie Three Idiots. That was actually the first time I saw a quadcopter flying or in general drones. The term drone being coined up. So that's I think that's a case with most of us. But what does come to your mind when you hear the word drone? Is it this image, or is it something like this, or something like this, or is it this? I think most of us would agree that the first one is what comes to our mind when we think about drones. But let me tell you, all of these pictures are termed as drones. So even the bigger aircraft you see on the top right is also a drone, and the small plane-like thing that you see on the bottom is also a drone, and this huge camera thing is also a drone. So let's just define what is a drone first. So it was coined up back in 1946. It's just a simple definition which says a pilotless aircraft directed by remote control. So if an aircraft on which a human is not sitting and it is being controlled remotely either by a computer or by the human, it's called a drone. So let's not use the word drone because it is very broad in general. So I'll just use the word aerial robots, and we'll classify the aerial robots as just basic things like multirotors. So multirotors are the class of aircrafts which have multiple rotors with more than two rotors, and they look something like this again. So the first image and the second image that you saw in the previous slide were multirotors. This is a class of a multirotor. As you can see, there are multiple rotors, and it uses these multiple rotors to generate lift and fly in general. So the other class of aerial robots can be categorized as winged robots, or winged aerial robots. So these are usually plane-like structures. Again, human does not sit on the plane. It's a remotely controlled aircraft or an autonomous aircraft without the human. So robots based on wings with usually a single rotor or a engine, or it can be a dual rotor also. But primarily, if it uses the wing to generate lift and fly, it's called a winged aircraft. And then there are hybrid aircrafts also, which use both. So it has wings also to generate lift. If people might know that how wings generate lift, I will not go in details, but we have an idea that wings do generate lift when flying in air. And if the aircraft uses wings to generate lift as well as multi-rotors to maneuver or do some actions, then it is a hybrid aircraft. So you can see first image and second image. If you try to combine and make something hybrid, this will be the result. So yeah, now let's just for today's session, we'll specifically revolve around multi-rotors and not the winged and hybrid aircrafts. And even in multi-rotors, we have to see what all kinds of multi-rotors are existing. So again, multi-rotors definition is very simple: a rotorcraft with more than two lift-generating rotors. So I think someone unmuted.
డ్రాగన్ ఫ్రూట్ కానీ ఏదో ఫ్రూట్ ఇవా యాపిల్ ఉందా
Ruchi, can you see? Okay, I think it's sorted. So please, can you mute yourself? I think it's Vijay. Okay, thank you so much. So classifying multi-rotors again based on the number of rotors, it can be classified as quadcopters, which by the name suggests they have four motors, and they look something in general like this, which they have four motors and some kind of body with some kind of landing. I think there is a lot of disturbance here. Someone has still not unmuted their mic or muted their mic. Yeah, coming back to the point. So usually that we see usual multi-rotors or drones or the aircraft that we see are usually quadcopters because they are very simple to make, simple to control, and they are very symmetric. And again, they are very famous till now. So this is what a quadcopter looks like in general. We have all seen this. Then little unusually used multi-rotors. multirotors are the hexacopters. But again, by the name, you can think that they have 6 rotors. Hexa means 6, and they have more rotors than the quadcopter. The reason, if you ask why if a quadcopter can fly itself and maneuver itself, then why do you need two extra rotors? So the answer can be if you want more thrust, more weight carrying capacity, or if you want more agility, more if you wanted to move the aircraft very quickly in all directions, this can be achieved using adding more motors. So similarly, we have octocopters. You add 2 more motors, becomes an octocopter. Octo, again, by the name, it is 8 copters. So you can see in the image, they have 8 propellers, 8 motors. And again, if you ask the question, why do you want 8 rotors if you can do the job with 4 or 6 or whatever? Then the answer is same. If you want to have more weight carrying capacity, you have to have more thrust. So those extra motors give you more thrust, and agility also increases. You can also actually use less number of motors than 4. So there are bicopters as well as tricopters that exist, and they do fly. They do stabilize themselves with little more actuators. But if you see the actuators here, which are actually uh, generating the thrust, generating the propulsion for the aircraft, they are 2 or 3. If they are 2, it's called a bicopter, and if they are 3, it's called a tricopter. But again, there are some rotating actuators inside. So these are very unusual, very uncommon, because they are difficult to control, difficult to manufacture, and yeah, they are not famous yet. So okay, that's about multi-rotors. And let's deep dive into the quadcopters, because again, they are very famous, they are very easy, they are very common. And let's see about the workings and the functioning of quadcopters in general. So yeah, as we all know, a quadcopter again has 4 propulsion systems, 4 propellers, 4 motors, whatever you call them, 4 thrusters, you can tell them. So they are usually, the 4 motors are placed in a square symmetric shape. Although there are unusual geometries with trapezium, you can see with a rectangle geometry. So here you can see it's symmetric. The distance between 1 and 2 and 1 and 4 and 3 and 4, every distance is same. So it's a square geometry. But as I said, there are unusual geometries also, which are recently being used for different purposes. So let's not go into that. But usually, for a quadcopter, the propellers are placed in a square shape. So they can be numbered in any fashion. Different protocols are being followed by different systems. So, but the point to note here is, if you see, 2 of the motors rotate in a particular direction, and the other 2 motors rotate in the opposite direction. So if you define it's a clockwise and an anti-clockwise, the motor number 1 and 3 shown in the figure rotates in the clockwise direction, and the 2 and 4. I think there's disturbance from someone else also this one. Okay, I'll continue this. So motor number 2 and 4 rotates in anti-clockwise direction. So this particular configuration is, it's not random. It's a specific configuration. So if you the point to note here is the diagonally opposite motors always rotate in the same direction, and adjacent motors across the sides rotate in opposite direction. So we'll see or figure out why is this the case, and why can't we just rotate all the motors in the same direction, or why this specific configuration. So we'll see in the next slide or how it flies first of all. So since it has only 4 motors, so there's a thumb rule, there's a rule of physics that says that the number of actuators will give you the number of degrees of freedom. So I'll not go into very detail about degrees of freedom and actuators, but if you see there are 4 motors and 4 propellers can be controlled, then you can have 4 degrees of freedom. You can move in 4 degrees, not more than that. Deepam, I think your mic is on. Can you please turn off?
Sir, can you please repeat?
Repeat what?
So these the thumb rule of physics, what you were saying.
Yeah, sure, I'll do that. So just a second. Is my screen still completely visible, right? No, not any problem.
Yes, sir, it's visible.
Okay. So what I was saying is this robot has four actuators. Four actuators meaning four moving parts, which are the four propellers. And in a robot, if you have, let's say, n actuators, at max you can have motions, independent motions in n degree of freedom. Now, what is degree of freedom? So let's say you are moving in a particular direction. Let's say this is a x-axis. So that's one particular degree of freedom. You can move in particular direction. If you can move in other direction also, that's other degree of freedom. So lateral movement as well as rotational movements are considered as degrees of freedom. So let's say the drone can rotate in a particular axis, the entire drone. That's one degree of freedom. Drone can, if the drone can rotate in another uh, axis, then it's a one more degree of freedom. So I'll explain what are the axes here. But what my point is, if there are four motors, at max you can have four independent degree of freedom. That's the rule, basically. So since we have four motors, we have four types of motion that a drone or quadcopter can actuate. So the first one is accelerate. What does accelerate mean? It will again. I think some people have muted their mics. Is Ruchi here? Okay. So yeah, what are the four types of motion a drone can, or a quadcopter, not a drone, but a quadcopter specifically, can actuate? Are acceleration. What does acceleration mean? Just speed up in a particular direction which it is pointing to. It cannot accelerate in any direction. It can only accelerate perpendicular to its orientation. Now, if the drone is flat and all the propellers, all the motors are at the same speed, it will just accelerate upwards. So perpendicular to the plane of the entire quadcopter. If the quadcopter is little tilted, and at that particular time, if all the rotors or all the motors generate equal thrust, it will just accelerate in this particular direction, which is perpendicular to the plane. I think that is understandable little. That if the drone is having a tilt angle, and at that particular time, if all the motors have the same speed, the same thrust, then the drone will, or the quadcopter will accelerate in that particular direction only. So that is one of the motions where we have all the motors having the same speed, all the propellers generating same thrust. So in that particular mode, we have acceleration. So now let's see what are roll, pitch, and yaw. So in the diagram, if you can see, there are some axes drawn, the red, green, and the blue axes. So these are the rotation axes. So if you see across the red axis, if the quadcopter tries to rotate, that particular rotation is termed as roll. And similarly, if across the z axis, if I try to rotate the quadcopter, that particular rotation axis is called pitch. And across the z axis, like the planar rotation, if I try to rotate the quadcopter in that particular direction, of you can see the arrow also moving in that particular direction. If the quadcopter is moving, that particular direction is called yaw. So you can define at max 3 independent rotation axis, which is roll, pitch, and yaw. If you have any doubt about roll, pitch, and yaw, you can ask me right now. I know it might be little confusing at the start, because first time when you are listening to all these terms, it might be confusing. But the diagram also tries to explain itself. So yeah. So now these are the three rotation axes that a quadcopter or any body has. So the thing is, the other three type of motion that a quadcopter can perform are the roll, pitch, and yaw rotations. So how does the quadcopter roll, make itself move in the particular orientation? So if you carefully think in this image, let's just be in this image. So can you see my cursor?
Yes, sir.
Yes, sir.
Okay. Can anyone try to guess how do I try to make the quadcopter rolling towards the left? Let's see. Can anyone just try guessing? Or if anyone already knows the answer, you can just try.
Sir, can you repeat the question?
The question is, now let's say the quadcopter wants to rotate in the roll axis that is shown in the diagram, just as in the as following the mark the arrow. It wants to rotate in that particular axis. How do I make that happen? How does the quadcopter do it by itself?
If I'm
Uh,
not
may
wrong, sorry,
Yeah,
continue.
sure, you can go.
Increase in
So
pitch.
we can slow down the motor number 1 and 3.
Okay, I think you are naming the motor number 1 as this particular motor or as the bottom left. And
Yeah,
top left
we can increase this one, the first one. Increase the speed
Okay.
of the motor.
Okay.
This one and opposite one. Yes.
I think you are in the correct direction. You are actually, the answer is correct. I think someone also wanted to try. Does do they have a different answer than his?
Yes, sir. I was just going to say the opposite, that we can reduce the speed of the left two motors.
Yeah. So one of the answer is increasing speed of the let's say left motors, or the other answer can be decreasing the speed of the other two motors. What will this do? So if you just try to draw a free body diagram of this particular quadcopter, see the rotation of the propeller is directly related to the thrust it generates. That is pretty clear, right? That is pretty intuitive. That the faster the propeller moves, the more the thrust it generates, and thrust is the force that gets the motor pushed. So if I want to rotate a particular body, I have to have imbalance in the forces. So if I just try to create imbalance by increasing the left two motors thrust, I can create the imbalance. And if I try to decrease that's one of the option, and the other option can be decreasing the right two motors thrust. That will again create imbalance. So this is the way a particular or a quadcopter can roll. So depending on the axis of movement it wants to rotate, it can decrease and increase the motor speed. Similarly, I think the answer is pretty clear for pitch. If I want to rotate the quadcopter in a pitch movement, how do I do that? I just
Actually, one doubt.
decrease this.
Actually,
Yeah.
how that in air, how it will automatically adjust, sir?
You are asking how will it automatically adjust?
In air, in quadcopter normally in fly in air only, sir.
Yes. Okay.
Based upon the wind direction, how it will adjust, sir? That
Very
rotor,
good question.
how it will adjust, sir? Normally, by movement of the air only, it has to plan.
I think your question is how does the quadcopter adjust its orientation by itself? Is that your question?
By itself, or we have to adjust that one, sir?
Yeah. So it's a good question. We will come to this particular answer during the end of the in the control systems part. So we'll see how does a human or a pilot or the drone itself or the quadcopter itself controls itself. So that we will look at the later part. But just now in this slide, I am just showing the working of the motions that we can do. We will solve that doubt definitely. So coming back to the pitch point, if I want to pitch the quadcopter, the answer is pretty simple. The back two motors, if I just slow it down, and the front two motors, motors that you can see, if I just turn them faster, there will be an imbalance created across the front and back, and it will try to rotate. So that's intuitive. But now the difficult part is how does the drone yaw? Because now the thrusters were pointing downwards in the quadcopter, and we can easily create an imbalance for rotating it across the roll and pitch. But how does the drone yaw? Because yaw, if you see, is a planar movement, the plane in which the quadcopter itself is situated, and all the propellers are situated. So can anyone guess how does the quadcopter yaw, or does anyone know already the answer?
All the propellers should rotate in the same direction.
Okay, you are going sort of correct direction, but the answer is not correct completely.
The diagonal rotor will different motion. One is clockwise, one is
भूख तो
anti-clockwise.
लगी है बहुत तेज।
Okay, I think what I heard is the diagonal motors should rotate at a different speed, and the other diagonal rotor should rotate at a different speed.
Yes,
Is that
sir,
what you're saying?
two anti-clockwise.
Correct. Okay, you're also very close. It's almost correct.
Sir,
Decrease the
varying
speed of
RPM
diagonal motor.
I didn't hear that. Sorry.
Decrease the speed of diagonal motor.
Okay, that will do the job. Yeah, answer is correct. That will do the job. So that will not do the job completely. So if you decrease or create an imbalance. So first of all, the principle that we are using here is the principle of rotational momentum. So that's again a physics law that if a particular body rotates around its own axis, it has a momentum. Just like if we travel at a particular speed, a body with a mass travels at a particular speed, it has lateral momentum, which is like we have studied it all in physics, that it's a momentum is a body has momentum. So similarly, a body rotating around its own axis also has rotational momentum. And now again, the rotational momentum of the entire body has to be conserved. So if I just, the very first question I had during the previous slide is why not rotate all the motors in the same direction? If I just rotate all the 4 motors in the same direction, so all we have all the rotors rotational momentum will be adding up, and it will be non-zero. It will not balance. It will not be a zero momentum. So the resultant is, since the system has to balance itself, system has to conserve its momentum, the drone as general will rotate in the opposite direction. If at all I move all the rotors in the same direction. So to solve that problem, what we are doing is rotating 2 motors in a particular direction and rotating the other 2 motors in the opposite direction. So if the direction is opposite, the momentum cancels itself in a ideal situation. If all the rotors are rotating in the same speed with 2 rotors being in a particular direction and the other 2 rotating in other direction, in that case, the momentum will be cancelled out and drone will not rotate in the axis. But now I asked if I want to move it in a particular yaw direction, then I have to create the imbalance. I have to create the difference. So as people give the answer, what we will do is the rotors who are moving in the clockwise direction, we will reduce their speeds, and rotors who are moving in the anti-clockwise direction will increase their speeds. So we have a difference imbalance in the rotational moment in both the directions, and we have the resultant is the system has to conserve its momentum. So the drone itself will move in the opposite direction. So I think that will be a little, this part would have been a little heavy, but we can, you can again watch other videos and learn about rotational momentum in general, and it will be clear how it does the yaw. So we'll move further. So we have seen now as the drone has 4 different types of movements. Either it can accelerate in a particular direction, which it is pointing right now, or at any given point of time. That is one of the motion. And the other 3 motions are rotation across the axis. So these are the only motions that a drone can, or a quadcopter for now at least, since it has 4 motors, can actuate. So using these 4 or combinations of these 4 movements, a quadcopter can achieve a given position or a particular velocity in the lateral direction, or do other movements like sometimes flips and rolls also. So that is them. Also takeoffs and all, that is in general. So these are the only 4 types of motions. So now the question is, now okay, I got to know how does the drone or the quadcopter behave, or how does it function. But I want to do it by myself. I want to experience it. So the question is, do I go and buy a quadcopter in the market? If yes, then which one? Or what is the cost of the quadcopter? But what if we are all almost engineers here? So science students are here, engineers are here, and most importantly, if you have the curiosity or the the excitement to do something by yourself, the answer is you should make your own quadcopter. So the question is how to make my own quadcopter. So let's see what all things are first required. Because if I want to make a quadcopter, I don't know anything about it. I want to know what all things are first required. Then what are the specifications of those and where to buy them, how to choose the right products. So first, let's make it simple. Let's just list down what all things are bare minimum to make my quadcopter. So very first thing is frame. I need a particular chassis or a a frame to hold my all my components together. As you saw in the previous diagrams, this is a frame. The red and white thing that you see, the chassis is a frame, and on top of that we have the components, the motors, the batteries, the electronics, and other things. So first thing to start is have a frame. Then to fly, obviously we need propellers. So propellers should be there. But to rotate those propellers, we need to have some actuator, which is a motor. And usually, since we are making a small version, we will go with electronic devices, which is a motor again. So we'll see which kind of motors should we use. And to drive these motors, it's not that simple. You just cannot connect it to the battery directly, and the motor starts rotating. That's not how it happens. So you have to have a motor driver. So again, to drive that motor driver, who will give a command to the motor driver? Should I give the command to the motor driver directly, or should there be a intermediate flight controller between us? So the answer is flight controller should be there. We'll later know why. So yeah, flight controller is one of the components that we need that takes care of all the computations and all the adjustments and intelligence on the quadcopter. So that is one of physical board has to be there, computer has to be there, small kind of computer has to be there, with the flight control. And then once the quadcopter is okay, flyable, how do I interact? How do I send it commands? So I have to have some kind of wireless system because I cannot make it wired. So I have to have a wireless system. It's a remote controller. So it has to be a device and its receiver has to be on the quadcopter. So remote controller transmitter and the receiver. And if you want to fly it, in an easier mode, you have to have a position feedback, position sensor, which is usually the GNSS. You might not know the term GNSS, but you might know the term GPS very well. So GPS is very known widely because we all have it in our phones and other devices. So it gives us position. So a general term for GPS is the GNSS thing. GNSS receiver is the thing that you need to put on the drone or the quadcopter. And finally, to power everything, we need battery. Since everything is electronics here, we need a battery and not a petrol engine or anything else. But yeah, battery is required for power. And finally, to do the flight controller has to have some kind of software running on it to do all the complex things for us. So the software or the firmware for the flight controller is also a very major thing to be required. So let's see the each of the parts in detail. So coming to the frame, that's the simplest part you can think of. Either you can make your own frame if you are good at designing, if you're good at thinking mechanically, then you can design your own frame with whatever materials you like. You can make it by wood, you can make it by aluminum, you can make it by carbon fiber if you are good at it. Just a second, I have to mute myself. Yeah, I'm back. So yeah, so what I was saying is we need a frame to start with, and you can build your own frame if you want to, or else you can just go and buy. Uh, you can just buy it from the market, and let's see how are the frames looking like. The previous that we saw, previous one, the red and white frame. This is one of the frames that is made of plastic. So materials do matter here, because if it's an aerial robot support copter, it's very agile, it might crash. So crashes are about to happen, and so the materials matter. So this is a plastic frame. You can choose like a little good looking, good aesthetic, so with more features, a frame like this one, which has a landing gear also. So and some more, like extra holders or compartments there. Or this the middle one is a plastic frame, but if you want it to be more durable, want it to be more strong and lightweight at the same time, you can choose a carbon fiber based frame. So it's a similar structure from the second one, but this is made of completely carbon fiber. So if you see the rods and the body is made of carbon fiber. So this is about the frame. So let's say you built your own frame, you designed it. It's a fairly symmetric frame. You built it by yourself or you bought it. Now what you need is propellers. So propellers again, you have to, let's not go into the details of what size and what all. You can find it later. But I'll just brief about the materials and types of propellers. So it's a single blade propeller, if you can see here. It has two blades, I think. So this is a plastic one again. This is a tri-blade propeller. The thrust will be little more, and you can also go with a 4-blade and continues. It continues. It goes till there is no defined. You can have a 5-blade, 6-blade. Even I have seen propellers with 32 blades, 64 blades like that. But to keep it simple, you can continue with 2, 3, or 4. And the materials again here matters. So the materials can be classified as the plastic one again. This is a plastic. This is a particular same bi-blade propeller, but in a carbon fiber form factor. It's completely made of carbon fiber, and very unusually you can also see wooden propellers also. So coming to the motors, which will
Excuse.
Yeah.
Can I ask a question on blades?
Sure.
Sir,
Sure.
why we need 3 blades, 4 blades, up to so many blades? What is the purpose of using multiple blades in a propellers?
Yeah, so that answer can be answered. The question can be answered in a aerodynamically supporting theory. But if you have more surface area and if you have more number of blades at a particular given velocity, the same velocity, you can have more thrust. So these are powerful propellers. So if you want to have the same motor, same velocity, but to want more power, then you can increase your blades. That's the simplest answer.
Okay, sir. Thank you.
But at the same time, you will decrease your efficiency. So, battery power will be draining a lot in that case. So, yeah. Coming to the motors part. So, again, let's classify. There are many types of motors, but let's just classify and see what all motors are being used usually in quadcopters. So, very common type of motor that we have seen in remote control cars or hobbyist toys here and there are the brushed motors. They look something like this or this. So I am sure the second image most of us have seen. So this is a usual, motor used in robotic toys or other things. So these are the brushed motors. I'll not go into details what are brushed and brushless and what are the advantages. But just for now, you can just remember these are the brushed motors, which are not that efficient, not that reliable, and not long lasting also. So you can think of brush motor as the bad guy. I am making an impression here, but you can think of it as a bad guy. The good guy here is the brushless motor. So it does not have, by the name, you can see this motor had brushes. This motor does not have brushes. So that makes the motor, more long lasting. It is more reliable. And very good. All the bad things are removed. So it does not heat up also that much. So they look something like this, and internally they look something like this. So there's a stator and the rotor. By the name, you can see the stator stays wherever it is, and the rotor rotates around it. So this is the type of motor, and let me tell you clearly that most likely, whatever quadcopters you might see around you, is made using brushless motors. A very small fraction of quadcopters that you see in the toy ranges or the small ranges use the very first motor that is shown in this image. Or among the 4 images, the very first motor that you see on the left is the motor being used for very tiny quadcopters. But apart from that, usually brushless motors are used. And if you plan to make your own quadcopter, this is what you have to go for, brushless motors. So now coming to motor drivers, as I said, motors are complex to be driven. You cannot just connect the power to the motors. You have to drive it through a driver. So again, there are 2 types of motors. There are 2 types of drivers also. So for brushed motors, we have simple drivers. These are usual, hobbyist or enthusiast components found in online stores and offline stores also. This is a L293D driver. I'll not go into the details here again. How does it drive? But coming to the more important point, which is the brushless motor drivers, these have a specific name. They are called as electronic speed controllers. So there is no fancy thing in the name. They are electronics and they control the speed of the motors. So that's why the name electronic speed controllers. And these are usually used for the brushless motors, and they look something like this. So you have 3 wires for the motors, 2 wires for the battery, and some signal wires to control. So okay, now we have our frame. Now we have the propellers connected to our motors. Now who will fly? Who will send the commands to the motor drivers? So as mentioned previously, we need a flight controller. So flight controllers, how do they look? So very famous flight controllers that we have heard about. Some people might have heard about if they are interested in drones or quadcopters. This is the PixHawk. So what is PixHawk? It's not a company. It's not a single board. It's a standard. It's a standard defined by a particular organization, and whoever follows that standard of manufacturing is termed as PixHawk. So this is one of the PixHawk boards, very old PixHawk boards that you see on the left. And similarly, there's again a famous term known as Ardu Pilot or the Ardu Copter flight controller. So similarly, the one of the organization had created a standard, and they had come up with this particular flight controller. But what you see on the rightmost for now, the black part is a general purpose flight controller. So you can, if you are good at designing electronic circuits or building them, you can design your own flight controller. All it has, the main thing to notice in all the 3 is it should have a microcontroller. So if people are from electronics or telecommunication background or electrical background, they might know what is microcontroller. But for other people, microcontrollers are microscopic computers basically. So they run softwares. You can put softwares in them, but they are very small in size. So in the center, if you see, we should have a microcontroller first thing. And the second important thing is we should have a sensor. Sensor for what? Sensor for rotational feedback. So let's say my quadcopter is flying or it is doing anything, but I want to know its orientation, its angle, its roll, pitch, and yaw angles. If I want to, just like we have seen compasses. Compass, what does a compass do? It shows us the north or shows us the angle with respect to Earth's orientation. So it just shows us angle in the yaw direction, you can say, if it's kept perpendicular. Similarly, we want angles in the roll and the pitch and the yaw axis. So we have a sensor for that, which is known as the inertial measurement unit. So we have to keep this particular term in mind, that inertial measurement unit, IMU, is the sensor that gives a feedback or reads our current angle. So how it does, it's a homework for you. Just search about IMUs or inertial measurement units, and you will get to know how it gives the angle feedback. So 2 things majorly required in a flight controller are the microcontroller, the computer, and the IMU, which is the sensor that should be present in all of the controllers that you use. And these are the commercially available controllers. If you have yeah.
Excuse me, sir. I have a question. Can I ask?
Sure.
So we are using PixHawk. So we have various variants of PixHawk, like for making autonomous drone, we use PixHawk. Am I right, sir?
You are correct. You can also with the Pixhawk and the Ardocopter, you can have the autopilot feature. So that is there, but you can also manually fly them. So it has
So,
features.
so which is like more stable, like Pixhawk Mini, Pixhawk, or Ardu Pilot? Like,
Uh, so this is a small problem in the question. The hardware is not defining the stability. It's about the software as well as the entire system in general that defines the stability. If your system is mechanically, badly designed, if there are, moving parts, moving arms, vibrations by the motors, then any of the flight controller being hardware or software cannot help the stability. If
so if I have make
yeah,
any like autonomous drone,
yeah.
so which controller I have to prefer, like Pixhawk in different variants of Pixhawk, like.
There is no preference. You can use any of them. That's what I was asking. I was answering. The hardware will not define your stability. The software also has a major role. So in Pixhawk, the software that you are using also has major contribution about the stability. So
So
it's
like
about how
mission planner, if I have mission planner software, then
it should be very like nicely stable. It should be good.
okay. So,
Okay.
so Pixhawk Mini is like for the upgradation, or like what? I mean, in Pixhawk, I have seen various variants.
Correct. As I said, Pixhawk is not a single computer or a single controller. It's a standard. It's a protocol that hardware is followed. So you have line. Look, I can just list down 50 microcontroller or 50 flight controllers in the Pixhawk standards. So it's not one Pixhawk or Pixhawk Mini or any other. There are a lot many, and also the hardware. Hardware generation matters. So this one, as you see, is the very old generation. The microcontroller and the sensor used are pretty old. If you buy the latest one with the latest sensors and latest microcontrollers, it might be definitely faster and give you better results.
Okay, sir.
Yeah. So continuing, now these are the flight controllers that you can buy off the shelf, and they have, as ma'am was suggesting, that they also have a flight firmware that goes inside, which is readily built by someone else. But as engineers, we do not like systems which are pre-built or just assembling things here and there. If you are interested, if you want to learn things, you can build your own flight controller. So all you need again is two things: a microcontroller and a sensor. So you can definitely use any kind of general purpose microcontroller. Just one shown here is the Arduino Uno. So this can be definitely used as a flight controller, and just adding the ILU sensor will make you good to go for the flight controller. So options are endless. You can buy so many. There are so many flight controllers available in the market with the different standards, and or else you can make your own with some general purpose microcontrollers. Okay. There's a spelling error. It should be remote controller here. But yeah, coming to the next part, you should have definitely a remote controller, because now let's say that drone is, or the quadcopter is ready to fly, but I want to fly it with my inputs, right? So I want to make it do particular thing, go to a particular direction, go to a particular position. So I have to have a particular interface to connect with the quadcopter. So we have all seen the basic remote controllers like this. We used to play in our childhood with the remote control cars and so this is kind of very big fat joystick, and its receiver is also present. So the big thing is the remote controller, which has an antenna, wireless antenna, and the small black thing that you see is the receiver part of it. So it will go on the quadcopter, and the transmission will happen wirelessly. But this is very expensive in general. So this particular variant that you see is literally cost 20,000 rupees. So everyone cannot afford this, and everyone does not want this complex thing. Okay, one more complex thing I can show you is the uh, controller within the remote controller with a display. So it will add more features. You can have your camera feed directly displaying on the remote controller. You can have other things displaying like the speed of the quadcopter, the position of the quadcopter, or you can have a particular interface on it. So this is again a expensive one, but uh, this is a app. So everyone has smartphones these days. So what we can do is we can just simply have a virtual joystick on our phone that will do the same job. So instead of the antenna communicating wirelessly, we can use our Wi-Fi. So this is what you can use if you build your own quadcopters, or try to modify the workings of existing ones. But if you are planning to make one, so and definitely we are all students, so we have budget constraints. So this will save us. So I'll just add a point that this particular app that you see was built by an intern at eYantra who came to the competition, performed well in the competition, got an internship in eYantra, and during our internships we built things like these. So this app was built by the student itself from scratch within the span of 6 weeks, and the motive was to eliminate these big fat huge controllers and have a simple solution and a common solution for us. So you can have any of these kind of joystick based controllers with some buttons here and there to control the quadcopter. Continuing, so now now the quadcopter is functional. It has motors, it has a flight controller, it also has a remote control interface with myself. But it has, if I want it to stay stable by itself, stay at the position where it is by itself, I do not want to give any inputs, and I just leave my hands from my controller, and I want it to stay at wherever it is by its own. So I need some kind of sensor to read my current position on the quadcopter, so that I can at least know where am I standing, and if I am at all moving because of the air or because of other disturbances, I have to correct myself. So some kind of sensor, some kind of feedback has to be there, and for that, as I mentioned previously, the GNSS, Global Navigation Satellite System, the receiver has to be there. As we all know, the working of GPS. GPS is one of the GNSS of USA. So let's not use the word GPS as a general term, because the general term is GNSS, and GPS is the GNSS of USA. We also have our own GNSS, which is NAVIC, if you might have heard about it. And other countries also have their own. For example, Russia has GLONASS, China has Baidu, Europe has Galileo, like that. So these are all satellite constellations, and in general, it is called a GNSS receiver. The receiver, what it does is, using the satellite navigation system, it gives you your position on Earth. So once you have a position on Earth, now you can use that to control your quadcopter's position. So again, photos of some receivers, common receivers. This is one of the receivers that it looks like small. This is the size of the receiver. You can also go with cheaper ones, or you can go with the higher end ones. So the right one that you see is a very expensive GNSS. It's a very accurate and high precise GNSS. So yeah, these are some images of GNSS. Finally, we need.
Sir, I have a question.
Yeah.
Sir, actually, I'm a little bit confused that in earlier slide we talked about IMUs.
Yeah.
So it also gives position, and GNSS also gives position. So
No,
what's the difference?
that is incorrect. IMU gives orientation. So current, whatever, let's say the angle of the drone is currently, it just reads out the angle. So let's say the drone is tilted at this angle. So at this particular position, it will read the same angle, as well as if it moves here and there, the angle is same. It will not, know the position has been changed. But you can only
Okay.
read the angles.
Understood, sir. So,
Okay.
okay, yes, sir. Thank you.
Sir, I have a question.
Yeah.
So, where we use telemetry then, like in remote controller and receiver? What is the purpose of using telemetry?
So telemetry is a very general term. Telemetry just means to and fro communication. So if I want to communicate to my quadcopter or my drone via some other device, which is like, if you see the remote controller itself was a device. Now they both are communicating. So this is a telemetry. This is a form of telemetry. And you can have other telemetry also, which now the remote control only sends some data, let's say the orientation or the position data. But if you want to have more information, let's say you want to have information about the position of the quadcopter, you want to know the current speed, current height, or other things. So you have to have some other communicating device from the quadcopter. So usually what you are talking about is the third telemetry system that we use. One more device that is used to communicate for other other details. So that is termed as telemetry separately, but telemetry in general means just transfer of data to and fro.
So, I'm asking like, if I want to give a height to a drone, so what would be the dead device like? See, my drone
So
can have a range of like something at the vertical height. So what it would like the device,
yeah,
what it can.
yeah, your answer, you had same answer. You have a third device which is a trans receiver, wireless transmitter and a receiver. So
Yes.
again, there are a wide range of products available in the market for this purpose also. So they are named as telemetry modules for the drone ecosystem. And depending on the cost and depending on the electronics inside, you can have different ranges. So again, if you have a transmitter and receiver at the ground and at the quadcopters range or quadcopters itself, then you can send data like height, you can send data of position and all to a long range. So there are devices available, but I have not listed that device here because that's not the bare minimum. It's not compulsorily required to fly the quadcopter. That's an optional device used for other features.
Okay, sir.
Okay. So if there are no more questions, I will proceed further. So everything is done. I think the motors are here, the sensors are here, the flight controller is here. Now to power everything, we need battery definitely. So let's just
Sir,
look
I
at.
have a question.
Yeah, please go on. Hello.
Sir, I have a question, sir.
Yeah, tell me.
Sir, I have a question.
And you can go with the question.
Sir, I have a question.
Hello. Am I audible?
Yes, Smith, you are audible. Whoever has the question, you are audible. Kindly go ahead with your question, please.
Sir, if I want more equipment added in receiver, that mean सर हम लोग को 6 चैनल दिया जाता है रिसीवर में या फिर 5 दिया जाता है उसको हम लोग एक्सटेंड करना चाहते हैं देन क्या करना होगा सर?
The answer is very simple. You have to buy a high-end receiver or a transmitter. So as you said, the receiver that you bought or the transmitter that you bought is a 6-channel. Simply go and search for a 8-channel or a 16-channel or a 10-channel receiver. So it's not that you can upgrade your existing sensor. It's not that way. The manufacturer has made that sensor. So you have to buy a different, not a sensor, the receiver. So you have to buy a separate receiver, which is little high end. I hope I answered that question. If yes, then I'll move forward. So batteries. So let's just name or see some kind of batteries that are commonly used. The very first one that we all know, we have it around all of us, which are the lithium-based batteries, lithium-ion, lithium polymer batteries. All around us, they are in our phones, they are in our laptops, they are in our earbuds that we are using, all small electronics. So in the last 10 years, this technology has developed a lot. So this kind of battery pack that you are seeing on the screen is usually used in quadcopters or other drones or aerial robots. Other kind of battery pack is like a cell kind of structure. So there are lithium-based cells also, just like the other ones that we use in our remotes and all. So, but they are actually based on lithium salts and lithium technology. So we can also build battery packs using the cells, not that commonly used in the quadcopters. And we can also have nickel metal hydride. It's a salt that is used to make batteries again. So it's a separate, not a lithium battery, but this is one of the common again batteries seen around in robots. But specifically for quadcopters and aerial robots, the first one that you see, the lithium polymer based batteries, the pouch type of thing, is usually used. So the last thing, now all the hardware things are taken care of, but at the end we have to have our software that runs some algorithms, runs some calculations continuously for us to be able to fly the quadcopter. So the last but not the least thing that is required is the software or the firmware that goes on the flight controller board that we chose earlier. So now there are no need to worry because it's a fairly complex piece of software. It is not that one can write in and learn very quickly. So there are options available already, pre-written codes, pre-made softwares on the internet, free for all to use. And some of them popularly used are the PX4 flight controller. Do not confuse yourself with PX4 and the PixHawk that you saw. They sound similar, but it is different. The PixHawk was a standard for hardware, and PX4 is the software that goes on those hardwares. So PX4 again is used for autopilot systems, as ma'am was asking previously. If you want to have autopilot feature, not the human to control it manually. So this is one of the very widely used systems, PX4. You can go and check about PX4 later. A similar alternative is Arduino Pilot. This is the system ecosystem for autopilots again, free to use for all. It's completely open source, and other stacks, software stacks for other kind of drones, not autopilots, but you can say FPV drones or the racing drones that are getting common these days. So firmware or softwares for those are Betaflight, and one of them is iLab. So there are lots and lots of more options available. Just as you chose your hardware previously from the market, you can also choose the software from the list of available softwares to put it on your hardware. Right. So this sums up what you all need to build your own quadcopter. The specifications of each one, you can do a little bit of research on the internet. What kind of motor, which propeller, which batteries you would want on the quadcopter. So let's go on to a little technical side of the aspect. Till now it was just general, talking about the parts, talking about the working of quadcopters in general and drones. So now this is what the technical session is about, the control systems. I'll try to keep it as simple as possible because this is a little complex subject in general, and people having little background might understand, but newbies might face difficulties. So I'll keep it simple, very layman language. So we had a question earlier that how do quadcopters stabilize by their own? So we have seen quadcopters being stable by their own, locking their position in the air, or doing other things by themselves. Now this is what we are seeing about the software inside. The software that I told does all these things. So how does it do? The question is, how does it do? How does it stabilize by itself? But before answering that question, the question to answer here is, how does the user first control? So before answering the question that how does the drone does it by itself, or the quadcopter does it by itself, how does a human first control the quadcopter? So the usual form of the control is the data from the remote control that we have is sent to the quadcopter as position commands or angle commands. So they are commands. They are not other things like motor velocity, motor voltage, motor current. They are not those commands. They are a little higher level commands. The commands that we send to the drone are that I want the drone to move at this particular direction, in this particular direction, at this particular speed. These are the commands that are being sent to them. But how does the drone make sense out of those commands? How does the drone actually implement those commands? So let's see the structure of control systems. So starting with basics. So we all know that quadcopter has motors which make them fly. But now the motors have the interface. We have to provide voltage. We have to provide the current to the motor. So obviously human would not want to change the voltage and current manually. So we have a driver that drives the motor. Now to the driver, what is the input? The input is RPM. Obviously, we will the driver just wants to know what RPM the motors have to be rotated, and it will take care of it. But again, the RPM has to be decided by someone. Is it us? Is it the user? So do you think sending them all 4 motors rotation speeds would be easy to control the drone? I have to take care of all the 4 motors, have an algorithm in my mind running continuously, moving all the 4 RPMs to make the drone move or the quadcopter move. Is that feasible at all? In fact, the human brain is not even capable of doing that. So we have to add a controller in between. And what is this controller now? What it does is, instead of user giving command to the driver directly, user gives command to the controller. And those are little easier commands. So the angle commands now. Now the user is just giving angle commands to the controller. This controller is taking care of the orientation control of the quadcopter. Now, what is the interface? So if I just let the controller know that I want the quadcopter to be tilted at 5 degrees in the pitch axis. This is my command to the controller. Now the controller has to make sure that the 4 motors are rotated or to be driven in particular fashion such that the 5 degree of pitch is maintained, and that will control the motor drivers or motors in general. So controller does my job. So how does it do? So let's just define the driver and the motor collectively as the quadcopter system, and then we have a sensor. Previously we saw there was a sensor that used to give us the rotation. Can anyone just recall it? Let's see how much attention are we paying in the session.
Sir, IMU.
IMU, the full form is
Inertial measurement unit.
Yeah, inertial measurement unit is the sensor that is used to read the current orientation of our quadcopter. So now if you see in the diagram, what is the job of the controller? Controller has 2 inputs now. Controller has the user angle, what the user wants. Yeah, feedback. You're correct. It is the feedback. The user gives it the angle. It has to go at 5 degrees. Then what the controller will read, what is the current angle of the drone? Is it 5 degrees? Is it 1 degree? Is it 0? Whatever it is. If it is not 5 degrees, it will know the error. Now, with some basic algorithms written inside, the controller will try to minimize that error. So it will try to take the entire quadcopter to that particular 5 degrees or whatever set point the user has given. So it knows the current reading, it knows the user's input, and it tries to match both. This is what the controller does in general. The firmware that it does in general. So it takes the angle inputs from the user, it takes the angle inputs from the sensor, and it drives the motors accordingly to perform the particular action. So this is the orientation controller. Now again, have a thinking that is it little more or is it okay for the user to give the angle commands? It is okay, we can fly definitely, but is it easier? So now you have a remote controller, and the 4 inputs that you have is the acceleration, roll, pitch, and yaw commands. So if you want the drone to stay at its given position, then you have to continuously make some adjustments. If the quadcopter is moving forward, you have to bring it back. If the quadcopter is moving right, you have to bring it left. So continuously you have to change your angles and as well as the acceleration commands. So these are the commands which are little difficult for the user to control. So what we do is just add one more controller. Now the user does not give the angle. The user gives a higher level command, easier command. It's the position command. So if the user just wants for the quadcopter to stay at particular position or to go in a particular direction at a particular speed. So do not confuse. Previously, the user was not giving any kind of speed or any kind of position. The user was just giving angles of the quadcopter. And now the user is giving the position level commands that either go to this position and lock yourself or move in this position at this particular rate, at this particular velocity. So the directions are easier for us to understand, the X, Y, front, back, and up, down axes. So we have to have a position controller to implement this. So what the position controller does? It takes the position input from the user and it converts to particular angles to the and feed it to the next controller that is taking care of the angles. So now is the diagram complete? Just the position from the user is enough. Is this enough? How does the drone or how does the controller know the drone's current position? Can anyone tell? Something is missing in this diagram.
The user should give the direction controls.
Yeah, user is giving the direction controls. But since if you compare the previous diagram, the controller diagram of the orientation, it had orientation commands from the user and it had orientation feedback from the quadcopter. So it can check the errors, it can check what has to be done. But now in this diagram, something is missing.
The GPS.
Perfect. So some kind of sensor is required for position. Till now, we do not have any position for sensor for position. So the sensors have to have a position command also fed back into the controller. This is what we mean as feedback. And I've just created the same block for both the sensors, the IMU and the GPS or the GNSS sensor. So again, the GNSS sensor's position commands will go to the, not commands, the feedback will go to the controller, and the controller has a similar job to do. Take position inputs from the user, read the current position of the quadcopter, and see how much error is that, and then with some formulas, with some algorithms, you convert those to actions in roll, pitch, and yaw. So now this is the complete, easy system that we have built, and this is called as a controlled system. So if you see quadcopter as a system, this existed just as a system. It was not controlled. It was not controllable as such by the user easily. But adding these blocks, adding the controllers for orientation, adding the controllers for position, and adding some sensors, we have created a controlled system. So this is what we mean by a control system. And then I think some of us might have subjects. Some of us might have already done these subjects. So yeah, this is what we mean by control system, and this is what is happening inside the firmware of the flight controller, and it physically runs on the hardware flight controller. This is the job continuously done by the flight controller, and it takes care of the orientation as well as the position of the quadcopter. So if you have any doubts about this control,
Sir, can I go?
sure.
Sir, the only doubt is that the software that we talked about, the PX4 Autopilot and the Audio Pilot, are those the systems that provide this service, or does this have to be designed by the programmer?
No. All the flight controllers that I mentioned previously does all these things, even lot more things apart from this. But yeah, this thing is taken care of by the flight controller, the firmwares. So no need to build the system by yourself if you want to start. But again, this is a very interesting part to do. This is what we teach actually. This is what an engineer does by them. Because again, just implementing work done by someone else on the internet is not a great achievement, right? Also, that's an achievement. You are actually implementing it. But if you want to, learn more things, learn in depth, you would want to, build this system by yourself. So this is what is the, motive that we teach through the competitions. So if you are, if you have taken part in the previous competitions in Yantra, you might have, or you might have seen the competitions, or if you take part in this year's competition also, we have these systems to be taught to everyone using the competition. So if in the competitions, usually students, build the entire system by their own.
Yes, so in I guess 2 years before the Vitran drone, there was one.
Yeah.
Yes, sir. So in that I saw something like I did not participate. So later I saw. So there was something like PID controller. So is it the same thing which is being
It's
told?
the same thing. Now I've not shown how does the controller function in the internal because it's very complex again. So it's not the scope in this session. So that is what I was talking about. That is what you will learn in the competitions that are there.
Okay, thank you, sir.
Yeah. Any other questions at this particular point about control systems? Okay, then I can move forward. So now, okay, till this point, we have made our own quadcopter. We have, taken care of the control systems, all the firmware that it has. Now it is able to follow human commands. But what if I want to make it completely? Yeah, someone had any question? I think no. Okay. So what I was saying is now the human is able to control the quadcopter in a position or an angle mode, whichever the human wants. But now if I want to, make it hands-free, make it remote control-free, and make it little more autonomous, then what to do? That's called a higher level planning. So you plan some things before. You tell the quadcopter to do this particular action prior to the flight, and then the quadcopter executes those steps or the motions or whatever actions in a particular sequential way. So then the user does not have to control it manually or make it go to a particular velocity or position. The quadcopter does it by itself. So how does that happen? So there are two stages of high level planning. One is called a mission mode. So this again, people who are familiar with PX4, Pixog, Ardu Pilot, Ardocopter might have seen this kind of, or just at least heard about this kind of thing, which is called a mission mode. Now, what is mission mode? Since we already have our GPS or GNSS sensor, we can give it coordinates in latitude and longitude on the Earth. So let's say your task is to, you just imagine you want the quadcopter to fly from your house or your building or a college and just go and land to other particular place, other particular building. You don't want it to, want to control it by yourself because it's a very long distance and you cannot even see the quadcopter. So now what you will do is, since the system is already built, the controllers are in place, the firmware is in place. All you can do, all you want to do is just give it waypoints, give it set points, and tell that first go to this particular point, then go to this particular point. You can just plan your path, draw lines on the map, and then set your home location, set your destination location, set your height to be flown at, set your speed to be flown at. So this kind of planning you can do on the quadcopter, and the quadcopter, if there is a right firmware and the right system is been built, will do it by itself. So you can see in this list, there's a map here, and there's a home location here. There are waypoints number 1, 2, 3, 4, 5, and then coming back. So this is what the particular mission that is designed is to just go around on these particular points and then come back to the home. So you can see down the interface lets you to add waypoints, add altitude, add speeds here and there. If you want to tweak details like how fast the drone should move up, how fast the drone should go here, and how fast the drone should come down, you can tweak all the things. And this is what a mission mode looks like. And all you have to do is send this mission to the quadcopter, and then just sit back and watch. So just turn on the switch. The quadcopter will complete the mission by itself and come back. So for this to be possible, you have to have all the right sensors, right system, and right flight controllers and firmwares inside. So again, this system that you are seeing is also a part of the competition that we built. The participants have a habit of writing their own autonomous codes that do all this planning. So now this is again, you can say this is autonomous, but again a human has to design all the things. And now just think what will happen if I give it a plan, give it 2 points to go from one point to other point, and actually there is a building between it. There's a tree in between the path. I just told the quadcopter to go from this point to this point at this particular speed, at this particular height, but the quadcopter does not know there's a building between. So what will happen? Now we are saying the quadcopter is autonomous, but does it know where about its surrounding? Does it know where there are obstacles? Does it know that it is going to be crashed inside and then it will be destroyed? It does not know at this particular point. So going for more autonomous things, there is path planning on board. So the path planning that we saw is done by humans, and the path planning that I'm talking about now is completely autonomous. So this is a little complex thing. Once you are familiar with this, you can go forward with this. So there are two basic scenarios. One is a known environment that you have a map. It's just like on Google Maps, we have details about everything. We have details about the buildings, information about the roads, sometimes information about the trees also, let's say. So if you have the environment pretty known, then the quadcopter, let's say, has information about the buildings, about the trees, heights, and all. Then in that case, if you are just giving a destination point, the quadcopter has to plan its own path, avoiding all the obstacles, and and reaching its path. So this kind of planning is in the known environment is solved using some algorithms. These are the names of algorithms that are shown on the left side. A star is one of them. I'll not go into the details, but I'll just list everything. A star is one of them, which is the very well-known algorithm to solve path planning. Dijkstra is one of the algorithm, which is a pretty common name. And rapidly exploring random trees is the algorithm to for path planning. So now let's say that's okay. We know when we know the environment, it's easier. There are buildings, there are trees. We all know them, but that's not the case always. Now just consider a hypothetical scenario of going to Mars. Now recently NASA had launched its the rover as well as the quadcopter, or not a quadcopter but a drone. It's a single drone on the Mars planet. So now the environment is not known. So in that case, how does the robot or how does the quadcopter or the drone in general plan its path, plan its journey, avoiding everything. So in that case, you have to have additional sensors. So to do anything, you have to have information. So if you want to know about the mountains or any kind of surroundings around you, you have to have cameras, intelligent cameras that let you know about the environment. So as soon as you add those cameras, add those processors which take care of all this, you have the system ready. And then the algorithms used are the simplest algorithm used is bug algorithm. If some people know, it's a fairly easier algorithm, bug 0, bug 1, bug 2. Then the complex algorithms are the VFH and 3D VFH. So adding to this again, this particular task that we are seeing right now, which we are thinking it's very complex, this again is done by just people like you, people in third year, second year, when they complete their entire competition and coming here for internships. So this particular part is done this year. We have completed this particular task, completely autonomous flights with the drones. Sensing the environment with intelligent cameras, and complex hardware, and making the quadcopter avoid trees and obstacles by itself. So this is not that complex if you think, because it's done by students like you guys in second and third years. So that completes a high-level planning, and let's just quickly go through what are the applications and current applications. What are the state-of-the-art things happening in the quadcopters or drone world? So many of these applications you might already have thought about, already have seen about, but I'll repeat. So delivery, again, very basic, very first thing that comes to my mind for our application is delivery. Why not just deliver parcels, deliver products from one place to another? It's very fast, it's very cheap, it's very not reliable as for now, but it can be reliable later because it's going autonomously. So you can have 2 minutes delivery, you can have 5 minutes delivery, and things like that. So this is happening. This is not future. This is happening in some areas where the government allows, and yeah, the delivery is fairly simple. So the payload is taken by the quadcopter, and it can have the mission plan. In agriculture, if you see, again, fairly an already known application. You can have the manual labor work of spraying, throwing seeds on the entire farm or spraying water. These things can be done very quickly with aerial robots. The one that you see here is actually a product of DJI. DJI is a very common, the Apple of the drone industry. So this is the DJI Agres drone, and it has, if you can see, there are so many rotors here. So I think there was a doubt by someone that why to add 6 copters or 8 copters when you can do the job with 4 copters. If you see here, this is a fairly heavy drone, heavy payload is attached to it. That's why you need more number of motors to compensate for that weight. So yeah, there are 8 motors here, and all sort of things like spraying fertilizers, spraying water, spraying seeds, throwing seeds, or even doing some kind of mapping or surveillance about the plants can be done by quadcopters in today's world. Coming to mapping again, mapping and photogrammetry is a very recent application of drones, and it is being used literally everywhere. So the maps that you see on your Google Maps, those are created by satellites. So satellites from the space take images on the Earth, and then there are processing happening, and they create maps. So if the satellite from that height, that range, can do that in a decent manner, just imagine how drones could improve the mapping thing and how quickly it can happen, because satellites take a lot of time to update. So some satellites take literally 6 months, 8 months to update your surrounding maps. But if you have drones flying around updating your maps, that would be so very quick and very accurate. So photogrammetry, the word photogrammetry here is very complex. What it means that you recreate reconstruction using photos. So let's say there is a someone unmuted. Okay, I'll continue. So let's say there's this monument or Taj Mahal. Let's just consider Taj Mahal. I want to have a 3D model of Taj Mahal. So how do I do that? So if that's possible with drones, you just fly quadcopters around or the drones around Taj Mahal, capturing some photos and videos, and using the information of those photos and videos, there are algorithms, there are processes that can recreate the entire monument or the entire structure. That's called photogrammetry. How to get drone license in Goa and how to join. Okay, I'll just take all the questions at the end, and we'll discuss about technical, non-technical policy level doubts at the end. So just keep your questions till then. Continuing, so photogrammetry is a recent, technology, and that is used and very, very useful to create, 3D structures, reconstructions, and can be used anywhere. So other commonly known application is surveillance. Authorities, police, or security scan simple. Again, transport is a little future from now. So there are companies actually building, vehicles like this for humans to travel from one place to other. It is happening, but it's not common yet. It will take some time to, be common. But yeah, this is one of the applications. Humans can sit inside. So if you see the first slide itself, when I showed you the definition of drones, it was said that unmanned aircraft. So now this is not no more a drone. This is a manned aircraft. But the structure that you see is not the like the usual helicopter that has single rotor. This is like again a quadcopter or a octocopter if you see. So the working is similar. The structure is similar. Just the human is now sitting inside. It has capacity to take that human and travel. So this is another future applications. This is the most common and currently being used current application of drones. It's the AL cinematography and photography. We have all seen events. We have all seen concerts in which drones are flying. Weddings are usually now. It's a very common thing wherein weddings are being covered by drones. The camera drones are used to capture shots for functions, for concerts, even for photography in around mountains, scenic photography and all. So that is there. The most commonly seen drones are the DJI drones. DJI is a company based out of China. And so coming to cinematography, there is a newer type of very exciting drone that we are seeing around is the FPV drone. So what is the FPV drone? What does it stand for? It stands for first person view. It's not the usual quadcopter or usual drone that people fly. You might have seen people fly cinematic drones which have the camera view to their screens and then they adjust their view. But this particular drone, how it flies is the human, the pilot, has a goggle which displays the camera. The camera is on the drone. It streams in real time to the goggle, and from that particular view, the human flies it. So as it is as good as a human is sitting on the drone. The human is piloting the drone, looking at the current, sitting on the drone. So this is a very exciting kind of drone. Why? Because it can do a lot more things than the traditional drone, the traditional DJI drones or any kind of photographic drones. So I'll just have a small,
Sir,
demo.
can you repeat it again?
Okay. I was saying about the FPV drones. FPV drones, how do they fly? Is the camera on the drone, just like you see here, there's a camera in the front. The camera streams the real-time image to the goggles. You have seen that VR goggles that are used for virtual reality, but not exactly virtual reality. The feed from the camera directly streams onto the goggles. There's a display on the goggle inside. And now when the pilot or the human wears those goggles, the pilot can see the view of the drone. It can feel it. It can feel that it is, the human can feel that he is sitting on the drone itself. And from that perspective, you control the drone with the joystick. So what happens is you can have a lot more agile control, a lot more acrobatic control. You can go at vertical angles. You can travel at vertical angles. You can travel at insane speeds. So I'll tell more about the speeds in the later slide. But this is the cinematography application of the FPV drones. I added specifically 2 slides, and I'll take more time on this because this is the current. It's not a future. It's the current thing, and all the production companies, films, and even the media is shifting on to this particular drones for their videography. So I'll just play this video, which is again by the FPV drone. You might not believe this is by a drone.
Smith, if there is any audio, that's not audible.
Yeah, the audio is not that important because it's a music
Cool.
running in background. Yeah. So that would have given a little posit here. So as you saw, it might have looked in the start that it's a normal drone footage, a stable drone footage. But then later you can see there it is doing, very acrobatic flips, rolls. They are doing dives and very agile control. It's very manually controlled. So this kind of, footages can be captured using this FPV drones. And there are lots and lots of videos around. You might be very surprised and very they are looking very cinematic. You can just, after this session, you can go on YouTube and search, or even now you can search about FPV drones in general and FPV footages in general, the cinematic footages. Coming back to the application, so one more application specifically from the FPV drones is the racing. Now, I think 99% of people might not know that there's a drone racing also possible. So just like F1 cars, we have normal cars and F1 cars. F1 cars are, high-speed cars, performance cars. And then what is it used for? Just for racing. So the people show talent, people show their skills, people show their hardware capabilities, and then they race. Similarly, here in the drone world, the FPV drones are used for racing. So again, they have the same structure. The pilot has a goggle. The camera on the drone streams the footage on the goggle, and the pilot flies using that particular view. So I'll just show you a race, which is like a recent race, and you can see the pilots and you can see how fast the drones are moving. We have a particular path or a track to go. These drones usually go up to 270, 300 kilometers per hour speed. So we can catch up with the fastest car in the world. This is a very increasing, sport. It's literally a sport where, you show your skills, piloting skills, and flying skills. So in the latest, I think, yeah, now you can see the perspective of the human. Human is actually seeing this view is goggle, and they are flying using this perspective. Yeah, I think I'll pause now. So yeah, these were about some applications, and I think the last part was little exciting, the drones. So you can, whatever we have discussed, you can, if you have more doubts, you can, if you want to learn more about them, you can try searching on Google. You can explore by yourself, and if you want to do things by yourself, I'll suggest you take part in one of the competitions. So eYantra always has one of the drone themes. Since the past 4 or 5 years, we have a drone theme in which every year we teach new kinds of new kinds of technologies, new kinds of tools and technologies, and yeah, we try to keep up with the latest trends. So the students, have understandings of quadcopters in general, all the aspects, hardware, software, higher level, lower level, everything. So yeah, that's about the session. I think we are done, and let's now take questions. I will read the chat. It's a long list, I can see. Wait a second. Okay, I'll read from the start. What is the minimum educational requirement for the competition, or minimum knowledge required for the competition, from Sajid? So educational qualification or requirement is just that you should be a student. And now we have opened it for everyone. You can be an engineering student, you can be a science student, you can be a commerce or art student also having interest. and having the enthusiasm in you. So there is no knowledge required for the competition. You will be treated as you know nothing, but you will be taught everything from scratch, and you will be given resources. And at the end of the competition, if you are reaching, you will be at a completely different knowledge. So yeah, you do not need any kind of prerequisites for participating in the competition. What is the requirement of Sentinel drone? Okay, I think you already know the name of the theme of this year, which is a Sentinel drone. Yes. Again, there is no requirement. All you would need to have is interest and motivation to complete. Uh, what do you study for the selection of test of the first step? I believe, to my knowledge, that there is no selection test this year. You can, Vivek, you can correct me if I'm wrong, but there is no selection test even this year. So no need to study anything. But yeah, you have to have your interest and motivation always. So let's see more questions. Will this session be uploaded on YouTube? Yes, it is being live streamed on YouTube. You can check later. All the if you have doubts in any particular, or you want to know the name of any particular tool or hardware or anything, you can go back to YouTube and check. Do we have any simulator to visualize the 6 degree of freedom of drones? Yes, we have so many simulators. So we include the simulation section in the competition always. And if you are not taking part in the competition, also you can explore by yourself. There are simulators available to simulate all kind of aerial quadcopters and other robots. Can we use Arduino controller with ESC? Definitely yes. We can use Arduino with any ESC. We can use smartphone to control. That's a very unique idea. You can use that, but it's a fairly unexplored area. You'll have to figure it by yourself how to do that. Can use Arduino controller? Yes. Which software is best for ROS? This question is little incomplete. ROS itself is a framework, and ROS runs on Linux. So itself is a software kind of thing, and there is no, there are packages inside ROS, but ROS is itself a software. If you want delivery purpose, does path planning works because every destination will be different every time? Yes, path planning has to be there, but at the same time, it's incomplete because you have to, have information about your surroundings when you are planning your path. How to get drone license in Goa and how to join classes for drone near you? So recently, from the last year, I think Indian government has formalized all the drone regulations and rules. So there is a detailed document, detailed rule released in March this year. So you can read them. It's very detailed, so I cannot add everything here. But drone license is a thing in India now. You can join just like for becoming a pilot of a plane. You have to have a flying school. Similarly, it's just for drones, there are flying schools around us. If you want to formally get a license, no need to go to flying school for learning flying. You can do it by yourself. But for license, you have to go to a flying school and then comply and give some tests, normal tests and formalities, and pay some fees, and you will be getting the drone license. So yeah, that is it. How do we get certificate for this session? I think it has been details are written on the portal itself, and you have to give this quiz that is at the end of the session. And if you give that quiz and perform nicely, decently, you will be getting the certificate. Do we have any simulator to visualize? Yeah, I answered that. Do FPV drone need license? So this is a gray area because if you read carefully the documentation, the licensing and regulations that are there are for commercial drones and for commercial purposes. So there is a separate sections for drones made by yourself, DIY drones made by people, not by the companies. So if you make a drone by yourself, you do not need no license to fly that drone as such. But there are regulations. So there are restrictions also, but there are regulations also. So you can do fly a drone in India. It's not that it's completely illegal, but there are regulations that you cannot fly in particular zones, particular areas. All those informations are available on the internet already. you can, if you are interested, actually, you can go to digisky.gov.in. This is the portal where all the regulations are mentioned. And in simple words, there are no-fly zones. So if you fly in the no-fly zones, you will definitely be in trouble. So there are green zones all around us. So you can go and fly in green zones. If you make your own quadcopter or own drone, and if you buy, you have to have it registered. Where is the link of quiz? I think people are asking for link. You will get in some time, or might have already got. So how to get into competition? So simple thing, you just Google eYantra, and you will be guided on the website how to register on the portal on the for the competition. The registrations I think are still open till 25th of August. So just register in the competition, and you will be guided later. I think the YouTube link has been posted. What is GNSS? Someone asked. So if you have missed the session, the GNSS just stands for Global Navigation Satellite System, and it is general term for something called as GPS that we usually know. That we have a sensor and it gives us position on the map or on the Earth. Why are we not using EDF for making drones? I think you're talking about material. EDF is, I'm not sure about EDF, what is it, but I think you're talking about the material that is, but yeah, I cannot answer this as I do not know what is EDF. Any GNSS model for drone which supports Navic? It's a difficult one to find now because Navic is pretty recent. And in fact, the matter of fact is that IIT Bombay itself is trying to make its own module for, GNSS for Navic. So it's still in development and it might be, available in some years. Why we use only propeller to thrust? I didn't get your question. Is it like why can't we use other thruster systems like just a fan or a engine? Is it that question? If that is the question, then it's propellers are very simple. You just apply it on a motor and it will create thrust. Other thrusters require fans, require high power motors. The ducted fans are talking about, or pressurized air might be needed. Or if there's an engine, jet engine, IC engine, it is very complex. How much one should score in the quiz in order to get an avail score, avail certificate? That details I think you might get later, but it's a fairly simple quiz. Just some basic questions that if you have paid attention in the session, it is very obvious. So any GNSS module for drone with support? Can you use plasma throttle in drone? Very futuristic, but not yet, I think, because plasma generates very little thrust and the weight is not, it cannot take up the entire weight. During the competitions, do we have lecturing sessions? Yes, we do have tutorials like and in talks like this, wherein mentors come or the instructors come with the participants to have some doubt clearance in once in a while, not every day, not every time. But we prefer forums for solving doubts. But once in a while, we do come and conduct sessions. So yeah, this kind of sessions might be there. Finding for questions. In control system diagram for drone, what is the reason behind connecting the output of sensors to the input of position controller? So that's the basic idea of feedback. Feedback just means the same thing that you have mentioned, feeding back the output, the input. So in layman language, I can explain that you have a reference point, and then you also want to know what is the current state of your system. So reference point is something that you would want the system to perform, and the current state of the system, you would want to see the difference. Like if I want to, make it rotate at particular angle, this is my set point 5 degrees, and 1 degree is the current rotation. So I know that 4 degrees is my error, and resultantly I have to, make particular motion. So this is in general that we have feedback. Please suggest a simulator for drones. I can, for different purposes, there are different simulations. For learning all this, we have Gazebo, we have Coppelia Sim, we have VBots for learning the piloting of drone. We have lot more simulators. Some of them are lift off, DRL. There is velocity drone. So lots and lots of simulators are there for piloting also. Can we use NVIDIA Jetson Nano? The object detection for the drone, and which type of camera will we use? This is for the advanced control that you're talking about. Yes, we can use Jetson Nano. It's a good computer. And the cameras required will be some kind of stereo cameras or depth cameras to have depth information. What is a quadcopter's cost? Good question. Again, it's a very general question. It depends on how high end you want to make your quadcopter. It can start with as low as 8,000, 10,000 rupees. You can also go very, very cheaper if you build your own things, like make it from wood, make it from aluminum, make it from cardboard. It can go to 3,000-4,000 also, and then it can go up to crores also. So yeah, it's a question of how much features do you want in your phone. But I'll say a general, very common range is 10 to 15,000. You said you can control drone using phone, control using Wi-Fi. Then what about range of Wi-Fi? It's a good point. Range of Wi-Fi is a limiting factor here. So if you control your phone, I think someone has it. Yeah. So coming to the phone controller, yes, Wi-Fi is a limiting factor here. Can you suggest simulator for drones? I already answered. What is the learning period and implementation period for the competition? So we can say learning is the entire period. You will learn always. You will first learn things and then do things throughout the competition. And implementation period is again the same. You first learn something, do something, learn something, do something, step by step. So the competition spans from September, October to March. So it's a 6-month competition every year. Which material is best fitted for framework apart from carbon fiber, because it's much expensive? You can definitely use plastic, not a problem, but it will, if it crashes, it will break, then you'll have to build it again. So in long term, if you see, carbon fiber is a little cheaper, although the one-time cost is more, but it will not break often. How will you identify our performance? Yeah, that is, the details will be given later. For this year's competition, we are working, are only working what? In drone areas. So I think your question is, are we only having drone competitions? No. eYantra has parallel themes. One of them is drone. So we have 7 to 8 themes this year, each focusing in a different technology, different stack. It's ranging from FPGAs, embedded systems, control systems, drones like this, complex hardware like mobile robots and manipulators also. So drone is one of the theme of among the 8 themes. What does it mean of mAh, which is written on the LiPo battery? It's a fairly simple concept. It's the capacity of the battery. You can simply Google mAh. Is there any 6-week training session before the competition? I don't know what training session are we talking about, but as such, there is no training session before the competition. The competition itself is a training. So yeah, during the competition, you will be trained. How can you program the drone? If any program classes are available, or do we need to learn on our own? You can, if you start, see, it's what, me, myself, and all of the people who are actually, having some knowledge, everyone has started from scratch on the internet. Just simply have to put your questions on the internet, put your questions on Google, and start watching videos, start reading blogs, start reading articles, and then you will know everything. So yeah, there are codes available. You don't need to start from scratch, but learning is always there. Can you teach making drone using NVIDIA Jetson Nano? There's no teaching as such in making drone. Just how to, once you are familiar with how the drone functions, how the drone works, till that point, it's clear how to use Jetson Nano to control the drone. But from scratch, there's no teaching as such. Yeah, I think we are done with the Q&A now. Okay, then I think time is also up. It's exactly 1 p.m. So we can answer your questions also later. And yeah, I think Vivek, they are asking link for the quiz.
Yeah, so we'll send the quiz link in chat. Before that, thank you everyone for joining the session, and thank you the YouTube live audience for watching our session. Hope it was helpful, and thank you Smith to conduct the session. Thank you.
Yeah, yeah. So okay, guys, see you. That was about it from my side, and I hope you enjoyed the session. I hope you learned little from the session. If some things might have been little difficult, I tried my best to make it simple, but you can always search on Google. So yeah, thank you everyone for joining, and see you later.